Logarithms. Y equals 2 to the x is an exponential function. And because it passes the horizontal line test, it has an inverse function. The inverse function of the exponential function is called the logarithm function. The graph below is log base 2 of y equals x. An easy way to draw the graph of the logarithm function is to draw it from the exponential function. So we know it's the inverse of the exponential function. So if we draw the exponential function and then we just reverse the x's and the y's, we should have the logarithm function, and the graph should flip across the line y equals x. So I have switched the x and y's. Let's graph that. So we have 1/4, -2. We have 1/2, -1. We have 1 0. Two 1, 4 2, and 8 3. Right, and if we draw our line y equals x, you can see that it does flip across. For x greater than 0 and b greater than 0, with b not equal to 1, y equals the log base b of x is equivalent to saying b to the y equals x. Notice in each one, the base is the same thing. So your base for the logarithm is the base on your exponential. The function f of x equals log base b of x is the logarithm function with base b. We're going to practice converting forms. So we're going to start with the exponential form and we're going to convert to the log form. All right, so first one, we have 2 to the third equals 8. If we switch to the log form, the log base 2, notice your base is the same, of 8 equals 3, which is your exponent. Right, your base in each one is the same, and the exponent is the answer to the logarithm. Right, the next one, we have 5 to the second equals 25. That's our exponential form. We're going to switch to logarithm form. Log base 5 of 25 equals 2. All right, we'll do the next two. All right, so we have 6 to the third equals 216. So we'll have log, our base is the same, so log base 6 of 216 equals 3. The next one, our base here, 10 to the fourth equals 10,000. To switch to logarithm form, we have the log base 10 of 10,000 equals 4. Now we'll start with the logarithm form and just go from there to the exponential form. So your base is going to be the same. So this is saying 7 squared equals 49. This is saying 9 to the -1 equals 1/9. 2 to the 0 equals 1. 4 to the 1/2 equals 2. Remember, to the fractional power is a root. So 4 to the 1/2 is the square root of 4 equals 2. Next, we have a couple of algebraic reminders about exponents. First, if something is raised to a negative power, like x to the negative 1, it is equal to 1 over x to the positive 1. If we have x to the negative 2, it is 1 over x to the positive 2. And x to the negative 3 is 1 over x to the positive 3. So if you have something to a negative exponent, remember it switches it to the denominator and changes the exponent to positive. Also remember that fraction exponents are equivalent to roots. So x to the 1/2 is the square root of x. X to the 1/3 is the cube root of x. X to the 2/3 is the cube root of x, and you can choose where to put the square. It can go inside or it can go outside. So it could be this way or it could go on the outside. Next, we will write each equation in its equivalent logarithm form. So we have 5, so your base is always the same, to the 4th equals 625. We have b to the 3rd equals 64. We have 3 to the y equals 7. Next, we're going to evaluate some logarithms without using a calculator. So we're going to try to switch the form. And so if we set this and write it like an equation, right, and we switch, we have 3 to the x equals 27. And we can think about this, 3 to what power equals 27? So 3 to the 3rd is 27. So our x is 3. Next, we try to evaluate log base 2 of 16. So switching our form, and we can go ahead and just call this, we'll call this x. 2 to what number is equal to 16? And this is one we could think about, and we could figure out that 2 to the 4th is 16. So our x equals 4. Our next problem is we want to evaluate it. 5 to what power is 125? So we'll just call this x. So 5 to what power is 1 over 125? So what we really want to do here is rewrite this side in terms of the same base as this one. If the bases are the same, then the exponents are going to be equal. So 1 over 125 is 5 to the negative 3rd. This is equal to 5 to the x. When you have the bases the same and your equation says they're equal, then the exponents are the same. So our x is equal to negative 3. To evaluate the next couple, we first have to switch out of the radical form to a fractional exponent form. So we'll call this x, and we have 2 to the x equals, this is 2 to the 1/5 power. And so we actually have this solved because our bases are the same, so our exponents will be equivalent. So for our next one, if we say this is equal to x, we will do 3 to the x equals, we'll change this form, 3 to the 1/7. And our bases are equal in an equation, so that means the exponents must be equal. So x is equal to 1/7, and we're able to evaluate. The next three are a little tricky. So we'll start with this one, and we're going to switch the form. So we're going to say 27 to what power is equal to 3. So that's not so easy to think of. What we want to do is write the bases the same. So we want to rewrite 27 as 3 to some power. Right? 3 to the 3rd is 27. Right? And then that is to the x. Now, power to a power, keep the base and multiply. So we have 3 to the 3x is equal to 3. Now our bases are the same. Our exponent on this 3 is 1. So we can make an equation out of our exponents. 3x equals 1 and divide by 3. So our x is 1/3. So we will set this equal to x, and we can change the form. 25 to the x is equal to 5. So we would like to rewrite the base on the left. So 25, we would like to rewrite it as 5 to some power. So 25 is 5 squared. So 5 squared to the x is equal to 5. And this is 5 to the 2x. And this will be 5 to the 1st on the right. Now the bases are the same, so you can set the exponents equal. 2x equals 1, and so divide by 2, and x equals 1/2. We have one more. So the logarithm base 64 of 8, we'll say this is equal to x. And we'll change the form. So 64 to the x is equal to 8. We would like to rewrite 64 as 8 to some power. So 8 squared is 64. And this is 8 to the 2x equals 8 to the 1st. Now our bases are the same, so we can set the exponents equivalent. So 2x equals 1. Solve for x, so divide by 2. X equals 1/2.